All right, this is the screencast for Lesson 3 of Unit 7, and we're going over weathering, erosion, and deposition. How do weathering, erosion, and deposition change Earth's surface? That's what we're going to find out. And by the end of this lesson, you should be able to analyze the effects of weathering, erosion, and deposition on Earth's surface features. All right, so we're going to flip to page 370 and get started. All right, weathering is the process by which rock breaks down into smaller pieces or changes in composition. Weathered rock pieces are called sediment. Okay, and sediment is an important part of soil. Soil is what you guys may call dirt, but soil scientists would definitely not call it dirt. But anyway, sediment, broken down pieces of rock, is an important part of soil. Weathering is caused by certain agents, such as wind, ice, and water. Gravity sometimes also. Okay, so a weathering agent is just the thing that causes weathering. Okay, wind, ice, water, gravity. Okay. There are two main types of weathering. I'm right here. Physical weathering, which is also called mechanical weathering. It's the breakdown of rock into smaller pieces. And then there's chemical weathering, which actually changes the chemical makeup of a rock. And I'm actually going to go tie that back to, y'all are like, where are you going with this? But when we reviewed digestion, there was the same sort of distinction when we talked about digestion. We talked about physical digestion, where things were broken down into smaller pieces. And then there was chemical digestion, where things were actually chemically changed, where we were making new compounds. Okay, so we have the same distinction for weathering. We have physical weathering. Excuse me, that is my phone. Okay, so I don't know exactly where I was because the phone rang, but here we go. We talked about physical weathering and chemical weathering, and I reminded you guys that we had the same distinction when we talked about digestion, physical digestion, chemical digestion. Okay. Over here, I wrote this out. This basically, it says it in here, but I sort of simplified it. Chemical weathering means that rocks are undergoing chemical reactions. They are changing their chemical composition because they're reacting with things in their environment. Usually that's maybe oxygen in the air or water that they're exposed to, things like that. Okay? All right. Over here, page 371, our topic is what causes physical weathering. Okay? So I'm at the top of page 371. All right, and there are several things that we're going to talk about that cause physical weathering. Remember, physical weathering is the breaking down of rock into smaller pieces. Okay? All right, we can have particles that scrape against rock. This process is called abrasion. If you've ever heard of somebody having an abrasion, that would be the technical term for a scrape. Okay, so it's the same sort of thing. Things that are scraping against a rock. That's physical weathering that is known as abrasion. Okay, wind can abrade rocks, cause abrasion, by blowing sand and other little particles against the rock. And it's sort of, if you've ever seen a sandblaster or a, one of those power washer things or whatever, that's basically what it does, is it's blowing little particles against the rock that's going to smooth and tear away little bits at a time. Okay? We can have abrasion occurring in streams where the streams are carrying sediment, and the sediment bounces along the bottom of the stream and hits against other rocks, things like that. Okay? We also have abrasion by glaciers, which are basically, glaciers are very slow-moving sheets of ice, and they basically act like a big bulldozer because they're being pushed down mountainsides, and they basically scrape whatever's in front of it along with it. Okay. Other things can cause physical weathering. Digging animals can break up rocks into smaller pieces. Plant roots can get into cracks within rocks and cause the cracks to grow and eventually the rocks to break. And we also have ice wedging or frost wedging. This is when you get water that seeps into cracks within rocks, and when water freezes, it expands, which puts pressure on the rocks, and it winds up cracking them and breaking them over time. And that's what is shown down here as an example. Okay. All right, I'm now on page 372. And it mentioned this on the previous page, but I haven't talked about it yet. Weathering is a slow process, and I'm right up here, I'm reading this part, that can occur over millions of years. But the rate of weathering partly depends on how much surface area is exposed to those weathering agents. Okay? If you have a lot of exposed surface area, then you have a lot of places where weathering can occur. And if you have only a little bit of surface area exposed, then weathering is going to occur more slowly because it can only occur where the surface of that rock is exposed. So, for instance, they're making a comparison. Let's say, for instance, you've got a single rock and you've got the dimensions here. It's 6 centimeters wide by 2 centimeters deep by 4 centimeters high. Well, in order to calculate surface area, you have to calculate the area of each surface. And if it's a rectangle, you have 6 surfaces. Okay? You have a bottom and a top. Okay? And in this instance, those are both going to be 6 times 2. Okay, so that's this part. You have a right side and a left side. That's going to be 2 times 4. That's this down here. And you have a front and a back, and that's 6 by 4, and that's 24. Okay? Now, you have 2 of these, okay, because it's top and bottom. Okay. You have 2 of these because one of them's the front and one of them's the back. And you have 2 of these because one of them's the right face and one of them's the left face. So when you add all of that up, top plus bottom plus back plus front plus left plus right, you get 88 square centimeters for your surface area. Okay? But let's just say that all we did was we split this in half. And so now we have still the same amount of rock, but now it's in 2 pieces rather than 1. Okay? So now the top and bottom of each is 3 times 2, okay, for a total of 6. The front and the back is 3 times 4, okay. So we've got top and bottom, front and back, 2 times 4, left times right. But that's only for 1 block, so we have to multiply all of that by 2 because there's 2 blocks. All right, well, if you said 6 plus 6 plus 12 plus 12 plus 8 plus 8, all of that adds together and you get 52 square centimeters. That's for 1 block, but we need to know for 2 blocks. So the total for 2 blocks is 104 square centimeters. So which has the greater total surface area, the original with 88, or the same size but split into 2 blocks? The 2 smaller blocks have the greater surface area. Okay. Would the larger rock or the 2 smaller rocks weather faster? The 2 smaller ones would, because there's more surface area exposed to weathering agents with the 2 smaller ones. Okay. All right, and we're going to go to page 373. Here we go. Now we're talking about chemical weathering. Remember that chemical weathering means that there are actually chemical reactions, chemical changes going on during the weathering process. All right, chemical weathering involves a change in the chemistry of the rocks. Two main agents that cause chemical weathering are oxygen and acids. Okay? We talked about water also, but it's typically the oxygen in the water that's reacting. Oxidation is a certain type of reaction where oxygen is combining with the rocks and forming new compounds. Okay? Acid can be a chemical weathering agent, particularly if we have acid precipitation, acid rain. Because of certain industrial processes and things like that, there are sometimes pollutants that are put into the air that combine with water vapor in the air and other things and form compounds that are acidic. And then they fall as raindrops, but they're more acidic than regular rainwater is. And that acid precipitation can speed up chemical weathering because there are some rocks that are more susceptible to those chemicals than others. Okay, so for instance, this is a great example. Do you see all the little pock marks and little holes and things in this rock? Well, this is a piece of limestone. And if you're unfamiliar with limestone, if you'll think of those white caliche gravel roads, that's basically limestone. So this is the type of rock we're talking about. Okay, carbonic acid over time will cause erosion, these pockmarks and holes because of the chemical weathering. Okay, one more thing that we haven't mentioned that causes chemical weathering is the metabolic processes of little microscopic organisms that may live on the rocks. Okay, they may release certain things like carbon dioxide as waste, which carbon dioxide plus water is going to give you carbonic acid, and that carbonic acid may react with the rocks. Okay, the orange over here, for instance, on this funny looking little rock, is because of the lichen that is growing on the surface of the rock, and you can have chemical weathering because of those little organisms called lichens that are living on top of the rock.